The next property, that is inverse property. What is this inverse property? This inverse property we have seen in the Boolean algebra also. In the lattice, complemented lattice, inverse means complement. Okay, so what is this property? For example, what is the inverse of 3 in multiplication? Inverse of 3, what that will be? Inverse of 3 is like this. What will you say? You will say 1 by 3. Many people will say 1 by 3. If I ask you what is inverse of 3, then many people will say 1 by 3. So which definition you are applying? What they are doing something like this. See, inverse of 3. Let's assume that inverse of 3 is, let's assume inverse of 3 is B. Then what they are doing like this. What should I multiply such that I get identity element of multiplication? This is the identity element of multiplication. So tell me, what should I put here? What should I put here? So this is the definition of inverse. Means 3 multiplied by B should be equal to identity element of multiplication. So what should be this B? So from here I can say B is equal to 1 by 3. Okay, so this is how we can define the identity. We can define the inverse. So for example, addition. If you notice, for addition, you know that if I ask you the inverse of 3, let's assume, then what should I put here so that I get identity element of addition? Remember, this is identity element of addition. This is the identity element of addition. So what should I put here? So this B should be equal to minus 3. So this is the 3 inverse. Okay, for addition operation, I can say that 3 inverse is basically minus 3 for addition operation. Okay, this is the idea. So now let's see the formal definition of this inverse. So what is the inverse? If you have any structure, you can have any set and this is some operation. Okay, then what is inverse of A? So what will be inverse of A? Let's assume inverse of A is B. Let's assume inverse of A is B. Then what it means? Inverse of A is B if and only if 2 things should happen. What should happen? A hash B should be equal to the identity element and B hash A should be equal to the identity element. This is the definition of inverse. So the inverse definition is very simple. Okay, inverse of A I am asking, then that will be B. Inverse of A is equal to B if and only if A hash B is equal to identity element, B hash A is equal to identity element. Both these things should happen. Okay, in such a situation, this B, okay, this B will be represented as A inverse. We will say that this B is the A inverse. Everything belongs to the base set. Everything will come from the base set. Everything. Always it will come from the base set. This A, B, everything is coming from the base set. Okay. Every element always will come from the base set. This is your base set. So every element is going to come from this. Okay. So this definition, just apply this definition. For example, like set of integers comma addition. If you take this, then here the identity element is 0. Okay. Then if I ask you what is the inverse of 5? So inverse of 5, just apply the definition. Operation is plus. This is your 5 inverse. This is your 5 inverse. This is equal to identity element. So what is 5 inverse? So 5 inverse is minus 5. So I can say for this structure, 5 inverse is minus 5. Okay. You also have to check. Remember, you also have to check that 5 inverse plus 5, that is also 0. So 5 inverse is equal to minus 5. Both these things you have to check. So in this structure, if I ask you what is A inverse, what is that? What is A inverse in this structure? That will be simply minus A. Correct? Like 5 inverse is minus 5. So in this structure, A inverse will be minus A because the identity element is 0. So basically, if I ask you what is the 5 inverse, then it means what should I add so that I get identity element. Okay, is it clear? So this is the purpose of I can say This is the purpose of this inverse. For example, tell me, if you have real numbers, comma multiplication, real number comma multiplication, what is the identity element? Identity element is E. So what is the inverse of 5? What is the inverse of 5? Inverse of 5 basically means what should I put here such that I get identity element? What should I put here such that I get identity element? So I should put 1 by 5. Okay. So in this set of real number comma multiplication, the 5 inverse, that will be 1 by 5. Inverse property, what it means? It means if every element has inverse. If every element has inverse, then inverse property. I can say this structure has inverse property. This structure has inverse property if and only if for all elements in this set, for all elements in the base set, A inverse exists. A inverse exists. For every element, A inverse should exist. For example, tell me, this structure, does it have inverse property? So the answer is yes. This structure has inverse property because for every element, like if I ask you, what should I put here such that I get identity element? What should I put here such that I get identity element? Your answer will be -2. So this is your 2 inverse. So you have 2 inverse. Similarly, what should I put here such that I get identity element? What should I put here? So you will say -3. This is your 3 inverse. If I ask you -10, what should I put here such that I get 0? Then you will say 10. So that will be the inverse of -10. So inverse of -10 is 10. So I can say for any element, so for any element, for all A belonging to integers, what is the A inverse? A inverse is -A. What is the inverse of 0? What is the inverse of identity element here? What is the inverse of 0? That will be 0 itself. Just apply the definition. Just apply the definition. In this, if I ask you what is the inverse of 0? 0 inverse, if I ask you, then basically I am asking what should I put here such that I get identity element. So what should I put here? I should put 0 here, and that will be the 0 inverse. Okay, what about this? Does it have identity? Does this have inverse property? Set of real numbers. This is your real numbers. So here you have identity element. Identity element is E. But do we have inverse property? This has inverse property. Can I say every element has inverse? Inverse property means every element should have inverse. Every element should have inverse. See, 5 has inverse. What should I put here such that I get identity element? So what should I put here? 1 by 5. So this will be the 5 inverse. But remember, okay, for any element, for 6, the inverse will be, if you notice, 6 inverse will be 1 by 6. But what is the inverse of 0? Tell me, what should I put here such that I get identity element? What should I put here such that I get 1? What should I put here such that I get 1? So does not exist, right? Does not exist. So I can say in this, there is no identity. This inverse property is not there because 0 inverse does not exist. I can say here 0 inverse does not exist. For the remaining elements, you have inverse. Like 6 has inverse 1 by 6, but this 0 does not have inverse. This 0 does not have inverse. So because every element does not have inverse, I can say, sorry, some elements do not have inverse, like 0 does not have inverse. So inverse property is not there. This structure has no inverse property. Okay. So this is the idea. What about set of natural numbers? What can you say about set of natural number comma addition? Do we have inverse property? Do we have inverse property? There is no inverse property. Why? Because there is no identity property. In this, there is no identity element. There is no identity property. We don't have identity element. If you don't have identity element, you can't even define inverse. To define inverse, you need identity element. Yes or no? In the definition of inverse, in the definition of inverse, we need identity element in the definition of inverse. So without this identity property, you cannot have inverse property. So basically tell me, if I say no identity property or no identity element, no identity property implies no inverse property, because without identity element you cannot define inverse. This concept you cannot define. Okay, so no identity property implies no inverse property. If there is no identity element, then you cannot define inverse, right? Yes or no? Any doubt in this? So what about set of rational numbers? Set of rational numbers, multiplication. Set of rational number multiplication. Here identity element is 1. Do we have inverse property? Do we have inverse property? The answer is again no. The same thing, because 0 inverse does not exist. What should I put here such that I get identity element? So this does not exist. I can say this 0 inverse does not exist. For the remaining elements, if A is not equal to 0, then for the remaining elements, this will be the inverse. For the remaining element, we have inverse. But now if I remove 0, see, the problem creator is 0, right? I can say the problem creator is 0. So if I ask you set of real numbers minus 0, now tell me, now this is closed, this is closed, this is associative because multiplication is associative. Identity element you have. Now do we have identity property, inverse property? Identity element you have, so you have identity property. There is identity property. What about inverse property? Can I say we have inverse for every element? Inverse property? The answer is yes. For every element now you can take any element. Now you can take any element. The inverse will be simply 1 by A. This will be the inverse. Same thing you can do if you have rational numbers. There is no problem. For the rational number also, this same will happen. Just remove 0. Okay. Q was rational number. This is set of rational numbers. This Q, this is the set of rational numbers. For subtraction, there is no identity element, so there is no inverse property. So that's the idea. Now tell me few interesting things about this inverse. This is my question. If A inverse is B, then can I say B inverse will be A? If A inverse is B, then can I say B inverse is A? Yes, very simple. Okay, very simple. Basically, if A inverse is B, so the answer is yes. If A inverse is B, because what this means, if A inverse is B, you are saying that A inverse is B. What this means, can anyone tell me what this means? This means that A hash B is equal to E, B hash A is equal to E. This is the meaning, right? A inverse is B. It means that A inverse is B. This is the definition. By definition, just apply the definition. Just apply the definition of inverse. Just apply the definition. What this means? A inverse is B. This means that A hash B is E and B hash A is E. This is the meaning. This is the definition of inverse. Now this automatically means that B inverse is A. This automatically means that B inverse is A. Because if you say B inverse is A, what this means? B inverse is A. What this means? This means that B hash A is equal to E and A hash B is equal to A is E. Just apply the definition, nothing else. There is nothing complicated here. Everything is very easy. Just apply the definition. So from this you can notice that from this I can say A inverse is B. From this I can also say that B inverse is A. So finally I can say that if you have A inverse, then its whole inverse will be A. So that's the idea. And what is the inverse of identity element? Tell me. What is the, if you have identity element E, so let's assume you have identity element E, then what is E inverse? What will be the E inverse? So the answer is simple. E inverse will be simply E, because let's assume this is the proof. Why? Because see, assume E inverse is B. Assume E inverse is B. Then what it means? Assume E inverse is B. What it means? It means E. It means E star B is equal to E. Correct? Yes or no? It means E star B is equal to E. B star E is equal to E. Now tell me, by the definition of identity, what should happen to B? What should be B? Remember, E star B should be equal to E. B star E should be equal to E. This is by the definition. This is by the definition that E inverse is B. You are assuming that E inverse is a B. This is what you are assuming. So it automatically means this. This is the definition of inverse. Because you are saying E inverse is B, then by the definition of inverse, this will happen, that E star B is equal to E, B star E is equal to E. This will happen by the definition of inverse. Correct? Now tell me, but E is the identity element. Now by definition of identity element, what should happen? So this will happen by definition of inverse. This is happening. By definition of inverse, this is happening. Now, because E is the identity element, so actually what should happen? So because E is the, since E is identity element, so what should be E star B? Tell me, anyone. Since E is the identity element, so what should be E star B? That should be equal to B. But you are saying that E star B is equal to E. So this and this, what they do? This and this. From this and this, what can you say? You can say E is equal to B. You can say E is equal to B. So E is equal to B. So B is equal to E. So I can say, so this is the idea. So remember, identity element inverse is always E. Hence proved. Hence proved. Yes or no? See what we did. We are assuming that E inverse is B. This is what we are assuming. We are assuming E inverse is B. And then we are finding that B is equal to E. Then we are finding that this B actually is equal to E. Okay. And what we have done, notice one thing. These things are very easy, extremely easy. Can you notice one thing what we have done? We have applied the definition of inverse and also the definition of identity element. Two things we have done. Definition of inverse, definition of identity element. Only two things I applied. There is no other thing that we did. Only the definitions we are applying. Understand the definitions clearly. Okay. So this is the proof. So identity element inverse will always be identity element. Tell me, in POSIT, when I use this symbol, does it mean less than equal to? Does this mean less than equal to? In POSIT, this symbol means partial order relation. This is the symbol of partial order relation. This symbol does not mean less than equal to. For example, I can say that you have set of natural number, comma, this operation, and I am saying A is this if and only if A divides B. So tell me here, in this example, what is this symbol? Can anyone tell me in this example? In this example, what is this symbol? This is divides, because we are saying that A is related to B if and only if A divides B. So in POSIT, this symbol means partial order relation, this symbol. Similarly, in group theory, this symbol stands for binary operation. This symbol stands for binary operation. So this is the symbol most people use for binary operation. Okay, in group theory, in this complete subject. So star does not mean multiplication always. If star means multiplication, I will make it clear. I will say that this is multiplication. If I don't say that this is multiplication, it means it can be anything. Okay, so like in partial order, in POSIT, this symbol stands for partial order relation. Similarly, in group theory, this symbol stands for binary operation. Is it possible for an element to have more than one inverse? Is this possible? Is it possible that some element has more than one inverse? See, many students who are saying no, they are saying no because they have already studied this group theory, and in group theory they have studied that for group this cannot happen. But I am not asking for group. For group this cannot happen. I am not asking for the group. Is it possible that element can have more than one inverse? And the answer is yes. It is very much possible. You can create. If you want, you can create counter. For example, consider this structure. Just consider this structure. Let me take these elements A, B, C, D, E. Okay, or maybe let me take this. Let me take this structure. And in this structure, what I'm doing, see, notice what I'm going to do. In this structure, I will make this E is the identity element. So let me make this as identity element. And what else I will do? For all x comma y other than E, for all x comma y, where x is not equal to E, y is not equal to E. Basically, all the elements other than E. Basically, all these elements other than E. For these, I will do this. X star y is equal to E. First, you tell me, did you understand this? What this means? Did you understand this? What I am doing? This simply means, so let me tell you, this simply means that, okay, E is the identity element. So E star A will be what? E star A, what that will be? That will be A, because E is the identity element, this is given to you. So A star E, that also will be A. That is fine. And I am saying that for all x comma y other than E, means for these elements. So for these elements, I am saying that A star B is A, E, B star A is also E, A star C is also E, C star A is also E, A star B star C is also E, and C star B is also E. So this structure, tell me, is it closed? This structure, is it closed? This structure I have given to you. In this structure, is it closed? A, B, C, E star. This is the structure. In this, is it closed? Can I say this is closed? Yes, of course, this is closed. Because any two elements you take, the result is in this. So this is closed. Do we have identity element? Is there any identity element? Yes, identity element is E. Tell me what is inverse of A. Tell me what is inverse of A. Inverse of A. What is that? Inverse of A. Let's assume that is A inverse. What is that? A inverse of A. Just apply the definition. Just apply the definition. Inverse of A. Let's assume that is A inverse. By definition, what should happen? This should happen by definition. By definition, this should happen, right? This should happen by definition. So here you can notice that A inverse is B comma C. Correct? A inverse is B comma C. What will be the inverse of B? That will be A comma C. What will be inverse of C? That will be A comma B. I hope this is clear. So this is the question. Is it possible that an element can have more than one inverse? Is it possible? The answer is yes. Inverse of E will only be E. Inverse of identity element will always, in any structure, whatever structure you take, if okay, identity element inverse will always be identity element only. Okay, so this is the identity element. So let's assume E is the identity element. So the identity element inverse will always be only the identity element. This will always happen. And proof we have already seen. I can say identity element inverse will be E. It can never happen other than E. The identity element will only be this. Okay, will never be some other element. Identity element inverse will never be some other element other than, this is never equal to some element other than E. Some element other than E. Other than E. The proof we have already seen, and this is the proof we have already seen, but anyway, let me give you. See, if E inverse is equal to B, this we have already seen, right? If E inverse is equal to B, then what will be B? We have already seen. If E inverse is equal to B, then what will be B? Then B will be equal to E. We have already seen this. Okay, so E inverse will only be E, nothing else. Is it possible that an element can have more than one inverse? Yes, of course it is possible. There is no problem. Like you can create this. Okay, so let's assume you have this structure. Your set is A1, A2, A3, and so on, AN, comma E, and this is your operation. Okay, and so the idea is this, that let's assume E is the identity element. So let us assume E is the identity element. Why I need identity? Tell me, without this can I define inverse? Without this can I define inverse? No. So I need identity element. So let's assume E is the identity element. And what I'm saying that for all x comma y, where x is not equal to E, y is not equal to E. For all x comma y means for all these elements. Basically, for all these elements, I'm saying that x star y is equal to E. Now, this structure you can clearly see. In this structure, what will happen? Okay, so in this structure, if you notice in this structure, this will be closed. This structure will be closed. Identity element is the identity element. And you can notice what will be the inverse of A1? What will be the inverse of A1? All these elements, inverse of A1 will be, A2 will be inverse, A3 will be inverse, AN. So what will be the A2 inverse? That will be A1, A3, and so on, AN. Actually, one more interesting thing. Sorry, A1 inverse will also be A1, right? A1 inverse will also be A1. A1 also will be there. Actually, all of them, A1, A2, AN. A1, A2, AN. Because just apply the definition. You can notice A1 inverse. If I want to find A1 inverse, then what that will be? A1 inverse is defined like this. What should I write here? Basically, A1 inverse is like this. This is the definition of A1 inverse. And you can put here, you can clearly see that A1 inverse, that will be A1 also. A1 inverse, that will be A2 also, and so on. A1 inverse, that will be AN also. Right? So here I can say that A1 inverse, B1 inverse is ABC, C1 inverse is ABC, and this is also ABC. So I just want to tell you that more than one inverse are possible. Okay? Is it possible that an element can have more than one inverse? Yes, that is possible.